you just visualize, make a smaller center which is inside the drone. Can you able to think? Drone konjam perusa seyano. Drone ivlo kuttiya irukadhu. Drone will be this much big, and the tower, whatever the tower which is in the ground to and the height, and the tower kuttiya irukadhu. Appudu solranga neenga yosichukonga. Adha kuttiya irukadhu. Drone perusa irukadhu. I am studying the reliability analysis of the drone, which is capable of all the ability in the sky. This is I am working with Russia. So I got a 3 years project, and one of my co-PA is also here from Jaipur. It's a team of 8 members. Nana PA, all 7 PAs all over the country. So already the Russian people, they made a drone. Moscow. He said, we are going to only artists we just went. We stayed for 10 days, we came back. We have seen the drone, and what we want, we have made it. So we are studying the reliability analysis of a drone also. I am having a recent project on same drone, which is for the government control. So I am working on the reliability analysis of the similar drone which is used for the multi-purpose. So in the time of 220, 10 more minutes. Adukula now 2 slide end slide. Okay. This is the abstract version of a whole country network. You won't believe, in your mobile, sorry, I go to that slide. Okay, so in your mobile, power point நீங்க பண்ற மொபைல் கால் ஒரு டவர்ல அக்சஸ் ஆகி சப்போஸ் அடுத்த எண்ட் காஷ்மீர்லயோ இல்ல சிம்லாலயோ இன்னொரு மொபைல் யூஸ் பண்ணிட்டு இருக்காருன்னா அந்த ஊர்ல இருக்கிற நெட்வொர்க் எல்லாம் போய் லாஸ்ட்ல அங்க இருக்கிற ஒரு டவர்ல கனெக்ட் ஆகும். இதை நான் கம்ப்ளீட்டா ஒரு ரிலேபிலிட்டியா நீங்க எல்லாம் போன் பண்ணும்போது உங்களுக்கு தெரியாது உள்ள என்ன வேலை நடக்கும். When you make a dial, that number all the way goes to the other end in nanosecond. அந்த நெட்வொர்க் எல்லாமே நல்லா இருந்ததுன்னா அந்த சைட்ல அவரால் காலை பிக் பண்ண முடியும் அப்படின்னு சொன்னதுக்கு அப்புறம் உங்களுக்கு கனெக்ஷன் கொடுத்து அப்புறம் பேச வச்சு அந்த ஒவ்வொரு பேச்சுமே நான் இப்ப பேசுற பேச்சு கூட ஒவ்வொன்றும் டிஜிட்டலா அங்க கன்வெர்ட் ஆகி அந்த பக்கம் அதே மாதிரி ரிவர்ட் ஆகி கால் போகும். இதுக்குள்ள உங்களுக்கே தெரியாது எவ்வளவு காம்பனன்ட் அதுல இன்வால்வ். இப்ப நீங்க யோசிச்சு பாருங்க, ஏதாவது ஒரு காம்பனன்ட் ஃபெயில் ஆனா உங்க கால் கட் ஆயிடும். அப்ப இதுவரை நீங்க பேசினது கால் கட்டே ஆகாட்டி அப்ப எவ்வளவு காம்பனன்ட் அதுல உள்ள இருக்கு பார்த்துக்கோ. எவ்வளவு மேத்தமெட்டிக்கலி there is a word called redundant. You know the meaning of redundant. ஒன்று ஒர்க் ஆகாட்டி அது பக்கத்திலேயே இன்னொன்னும் ஆன்லேயே இருக்கும். நம்ம வீட்டுல ஸ்டவ்ல ஒரு இது ஒர்க் ஆச்சுன்னா திடீர்னு அடுத்தது ஆன் பண்ணி போட்டுருவோம்ல, அந்த மாதிரி redundant system everywhere redundant so that the complete network is on. So I do the complete study on the whole network. So I am passionate to learn ஒவ்வொரு காம்பனண்ட் என்னென்ன வேலை பண்ணுது, எப்படி பண்ணுது, அதுல மேத்தமெட்டிக்ஸ் என்ன, அதுல எப்படி ஸ்டடி பண்றது, அதை எப்படி புரிஞ்சுக்கிறது, அதை எப்படி உள்வாங்கி அதை அனலைஸ் பண்ணி ரிசல்ட்டை கொடுக்கிறது, அதுல நான் கொஞ்சம் ஆர்வம். இதெல்லாம் ப்ராபபிலிட்டி அதெல்லாம் யாரெல்லாம் படிச்சிருக்கீங்களோ அவங்களுக்கு ஓரளவு தெரியும். யாருக்கெல்லாம் MATLAB தெரியுமோ you can make out. MATLABல அழகா ஒரு ப்ரோக்ராம் பண்ணி whatever you got the result you can visualize in the graphs. So நல்ல கிராஃப்ல படம் போட்டு பார்த்து, அதாவது ஒரு டவரை பண்றதுக்கு முன்னாடி இப்படி ஒரு டவரை இந்த இடத்துல பண்ணுனா என்னென்ன மாதிரிலாம் வேலை செய்யும் அப்படிங்கறது பிரிடிக்ட் பண்ணும். நான் வந்து கொரோனா 2 வேவ் 2 ப்ரெடிக்ட் பண்ணேன். மே வரைக்கும் உள்ள டேட்டா வச்சுட்டு அக்டோபர்ல வேவ் 2 வந்து குறையும் அப்படின்னு சொல்லி என்னுடைய மேத்தமெட்டிக்கல் மாடல், ப்ராபபிலிஸ்டிக் மாடல், டேட்டாவெல்லாம் யூஸ் பண்ணி மெஷின் லேர்னிங் டெக்னிக் எல்லாம் அப்ளை பண்ணி மே டேட்டா வரைக்கும் வச்சுட்டு we predicted, we got the same. So I'm happy to say that my predictive analysis with the corona wave 2 I was able to make it. So இது mathematical study. இதுதான் என் slide. Whatever the questions you can ask me because I don't want to waste the time. Okay. Any questions you ask me, I'll answer. பக்கத்துல கேட்க சொல்ல என்கிட்ட கேட்குது. எனி கொஸ்டின் சொல்லுங்க. உங்களுக்கு ஓகே. ஸோ எங்களுக்கு வர்ற இஷ்யூ எல்லாத்தையும் நாங்கள் என்ன பண்ணுவோம்னா, யார் எங்களுக்கு ஒர்க்கை கொடுத்தாங்களோ அவங்க கிட்ட நாங்கள் சொல்லுவோம், இதெல்லாம் உண்மையா, இதெல்லாம் கரெக்ட் பண்ணா, எங்களுக்கு இதுல டவுட் வருது, இது எங்களுக்கு தப்புன்னு தோணுது, இது வந்து கரெக்ட் கிடையாது அப்படின்னு சொல்லி எங்களுடைய அப்சர்வேஷனை வந்து அவங்க கிட்ட சொல்லுவோம். அப்போ வந்து அவங்க என்ன சொல்லுவாங்கன்னா, நாங்க எங்க ஆபீஸ்ல போயிட்டு நாங்க கிராஸ் செக் பண்றோம், நீங்க சொல்ற பாயிண்ட்டை நாங்க ஞாபகம் வச்சுட்டு எங்களுக்கு அந்த ப்ராப்ளம் வரும்போது நம்ம எப்படி உடம்பு சரியில்லாம டாக்டர்கிட்ட போய் கேட்கிறோமோ அதே மாதிரி எங்களுடைய இஷ்யூவை நாங்க அனலைஸ் பண்ணதை, மேத்தமெட்டிக்கலா அனலைஸ் பண்ணதை நாங்க கொடுக்கும்போது then they say that சார் நாங்க எழுதி வச்சுக்கிறோம், எங்களுக்கு இந்த மாதிரி ப்ராப்ளம் வரும்போது then we will come back to you அந்த மாதிரிலாம் சொல்லுவோம். So we have given the feedback to them. Thank you. I have a question. Any other question? Sir. Okay. நான் நாசாவுக்கு போகணும்னு நினைச்சது கிடையாது, அதுக்குன்னு நான் எஃபோர்ட் போட்டதும் கிடையாது. whatever the task is given to me, my teacher, I just did it. பட் நான் அங்கதான் போவேன்னு நான் நினைச்சதே பார்த்தது கிடையாது. இன்னும் நான் ஆதிபட்டியில இருந்து மெட்ராஸ் போறீங்க கூட நினைச்சது கிடையாது. ஸோ எனக்கு ஒரு கசின் வந்து ஒரு புக் கொடுத்தாங்க. அந்த புக்ல ஃபர்ஸ்ட் லைன் இன்னும் ஞாபகம் இருக்கு, முடியாதது என்பது முயற்சி செய்யாதது. தட் மீன்ஸ் the impossible one which is never tried. I believe in that word. So நான் நைட் வந்து தூங்குறதுக்குன்னு சொல்லி டைம் ஃபிக்ஸ் பண்ணவே கிடையாது. எங்க அப்பா கொத்தால் சைடு மார்க்கெட்டுக்கு காலையில 2 o'clock போவாங்க. அவங்க போறது நான் பார்த்துருக்கிறேன். நான் சாயங்காலம் 4 மணில இருந்து 10 o'clock வரை டியூஷன் எடுப்பேன். காம்படிஷன் ஒவ்வொரு பக்கமா சைக்கிள் எல்லாம் நடப்பேன். 10 மணிக்கு தான் நான் படிக்க ஆரம்பிப்பேன். என் பாடத்தை 2 மணி வரை படிப்பேன். 2 to 6 தூங்குவேன். 6 o'clock எழுந்திரிச்சு 8:15 எங்க கிளாஸ் சிஇஜி அண்ணா யூனிவர்சிட்டி. So I am the task master. I never fix the time for to sleep. இந்த வேலை இந்த சாப்டர் நீங்க முடிக்கணும், இப்படி காலை வச்சுட்டு பாத்தீங்கன்னா இந்த பக்கம் ஒரு கிழிச்ச போர்டு, நம்ம தூங்கலாம் போடல, அந்த போர்டை வச்சுட்டு இந்த பக்கத்துல ஒரு ஃபர்ஸ்ட் பேஜை மட்டும் பார்த்துட்டு நான் பாட்டு எழுதிட்டே இருப்பேன். அடுத்த பேஜை திருப்பினா அதை பார்க்கவே மாட்டேன். ஸோ எல்லா ப்ராடக்டையும் எழுதி பார்த்துட்டு போயிடுவேன். என்னுடைய புக்ஸ், நான் படித்த புக்ஸோட ஃபர்ஸ்ட் பேஜ்ல இருந்து லாஸ்ட் பேஜ் கூட மனப்பாடம். எக்ஸாம் முடிச்சுட்டு வந்தேன்னா பசங்க எல்லாரும் பாஸ் ஆயிடுவாங்கன்னு சொல்லும்போது நான் சொல்லுவேன், அநேகமா எனக்கு 1 மார்க் குறைய சான்சஸ் இருக்கு. ஆர் ஐ டெல் தம் ஃபுல் மார்க். டீச்சர் வந்து ஒன்லி டிக் மட்டும் போடலாம், டிக் போட்டு ஃபுல் மார்க் போடலாம். இட் கேனாட் டச் இன்டு தட். ஐ அம் டெஃபினட் கான்ஃபிடென்ட். ஸோ ஐ அம் வெரி ஃபோக்கஸ்ட். வேற என்ன கொஸ்டின்? எனி கொஸ்டின்? Any question? The next teacher is waiting and I don't want to waste my time to the other teacher. And நான் இங்க வந்து வைஷ்ணவா, நான் பிரசிடென்சி படிக்கும் போதெல்லாம் வைஷ்ணவாக நம்மளாம் போக முடியாது, நம்மளாம் சாதாரண பயிலுவோம், இங்கே வைஷ்ணவா தான் அப்படி தூரமாக தான் பார்க்க முடியும்னு நினைச்சேன். I am happy to be here after so many years. Thank you.
Thank you, sir. Thank you for your wonderful session. Any other questions? Any more questions?
Hello. Oh yeah.
A warm and pleasant greetings to all for this first day, third session of International Conference on Applied Mathematics and Computing, ICAMC 2023. It's my great pleasure to welcome our Secretary, Dr. Ashok Kumar Mundraji, Principal, Captain Dr. Santosh Babu sir, Professor R. Venkatamanan, Head, Department of Postgraduate and Research Department of Mathematics and Controller of Examination. It gives me an immense pleasure to welcome our eminent resource person, Dr. Usha Mohan, Professor, Department of Management Studies, IIT Madras, to enlighten us on this topic, Operations Research Models for Better Decision Making. I welcome all the faculties and research scholars from the various institutions. Once again, I welcome all the participants from various colleges and students for this session. Welcome everyone. Good teachers know how to bring out the best in students by Charles Kuralt. With this quote, it's my honor to introduce our resource person, Dr. Usha Mohan, Professor, Department of Management Studies, IIT Madras. Ma'am has completed her PhD in Operation Research from Indian Statistical Institute, India in 2002. Her PhD thesis title on Symmetric Traveling Salesman Problem, Some New Insights. MPhil in Operation Research from University of Hyderabad, India in 1992. MSc Statistics and Operation Research from University of Hyderabad, India in 1991. BSc Mathematics, Physics and Electronics from Osmosnia University, India in 1989. Ma'am has more than 20 years of experience in teaching. Currently, she is working as a professor in India IIT Madras since 2019. She has worked as a lecturer in University of Hyderabad from 2007 to 2010 and in Indian School of Business from 2004 to 2007. Ma'am's areas of interest on quantitative models in supply chain management, combinatorial optimization, mathematical programming. Ma'am has organized many conferences, seminars and workshops. Ma'am has delivered many invited talks in various national and international conferences. Ma'am has published research articles in many reputed journals. To mention a few, a credit scoring model for microfinance case study from India, accepted for publication in proceedings of the Inclusive Financial Innovation Making Finance and Insurance Markets Work for the Poor, workshop organized XLRI 2012, impact of avian influenza in the Indian poultry industry, a supply chain risk perspective with Vishwanathan and Praketrika in achieving rural and global supply chain excellence. ISB Glance Research Publications 2006. With this short note, I hand over the session to you.
Thank you. Good afternoon, everybody. So, even though I speak Tamil, I'll not talk in Tamil because my Tamil is not that good. As you may see that I grew up in Hyderabad, so my Tamil is only at a conversational level. However, when I prepared these slides, I thought it was for a research scholar and faculty development. But since I see a lot of students, I'm going to change gears. And I'm going to give you, hopefully by the end of my talk, I'll be able to motivate you to look into some problems in decision making and how what you're learning during your MSc or BSc could help you achieve that. Okay, that is what I'm trying to do. So how many of you have smartphones here? All of you, very good. How many of you use them? Other than Instagram, Facebook, and WhatsApp messages, for what purposes do you use it? Anybody uses maps feature? Yeah, what do you do in a map? So what is the purpose that you want to do? Why do you use a map? You want to see the route. If the map gives you 2 or 3 routes, what do you do? That's an optimization problem. Do you all agree? Given a choice, always when you are presented with choices, you want to make a decision. Is that clear? When do you not make a decision? When you are given only one choice. Right? And it's not called a choice also, when you are mandated to do something. So every time we are faced with choices, our job is to take a decision. That could be right from choosing a college, choosing a course, choosing a job, choosing a life partner, to everything, right? You are presented with choices and your job is to take a decision. Okay? How easy is it to make this decision? Or is it tough? Is it easy to make the decision or is it tough? Tough. Why is it tough? How do you generally make a decision? Suppose you took a decision to come and join this college. Was this the only choice given to you or were you given a lot of choices? Why did you decide this? At the back of our mind, we did some analysis. And what is the kind of analysis we did? We ranked them in some order. Okay? Distance from home, faculty, placement, if you're interested in jobs, okay, and friends, everything. You put everything and then you rank it in some order to finally come with the decision of, okay, this seems to match all my criteria, let me go with it. So finally you have whatever we do intuitively, okay, that is actually a process, okay. And that process helps us in taking decisions. Now you might ask, why is this lady talking about decision making in a mathematics seminar? The reason is there's a lot of math into it. There's a lot of math modeling that actually goes into it. How many of you use Amazon to buy e-commerce? BB Now, Big Basket, Swiggy. How many of you order on Swiggy? In Swiggy, they say that time to reach. There's something called within this time. How do they know that it is going to reach within a time? They are optimizing somewhere, right? Now, if you all know Big Basket has come with a BB Now, 15-minute delivery, 10-minute delivery. How do they manage all of that? All of this is operations research. Okay? Everything is about operations research. So you just look around you and you know that OR is applied in almost every field, every decision that we take on a daily basis. Okay, this is at an individual level of decision making. Now if I go to a collective decision making, what do I mean by collective decision making? If I'm looking at a college or if I'm looking at a company, if I'm running a company, what is my primary objective? If I'm running a company, what would be my primary objective? I would want to make the least profit or the maximum profit. If I'm going to have an objective of making a least profit, I'm mad. Right? Okay? But if I am a person who is seeking to maximize my profit, I should do this only under some constraints. Right? Not things is always very easily available to us or not. So, how do I maximize my profit? That becomes the decision problem. Would you all agree? Right. How many of you have experienced queues? I saw in the lunch also today, all of us are standing in a queue. Right? How fast did that queue move? Was it very slow? Was it very fast? Was it irritatingly slow that you prefer to stay hungry than stay in the queue? So you see that again, you would have felt, okay, instead of one person serving rice, had there been two people serving, it would have been faster. Right? That is a decision problem. How many people should be serving a dish? That's a decision problem. That decision problem also can be modeled as a mathematical problem. Is it clear? And that's what queuing theory does. So, to just start my work, I don't know whether I can play a video. Is it possible? Can I play this video? I just need access to YouTube. This is a brief history of OR. So as they get ready, this is just an introduction or origin of OR. It's about a 3-minute video. What I want you all to see in this video is how mathematics as a discipline gave rise to this entire discipline of operations research. Okay, and as students, what I want you to believe is, don't think maths is only about X's and Y's, and algebra and analysis, okay, and abstraction. If you know your subject well, you can contribute a lot to the society and towards decision making. Okay, I just want you to go through it. Thank you.
Began in the First World War when science produced in order to improve on military operations. In February 1917, German U-boats intensified their assault on Britain's Atlantic supply lane, sinking 1 in 10 ships sailing every month. British scientists analysed all available data and created the best possible model to help the convoys survive. They were optimised for size, speed and timings for sailings. Just 6 months later, losses were down to a remarkable 1 in 200, not only saving lives, but critically contributing to the survival of Great Britain. By 1934, analysts had identified a new problem. Simulations showed that in the event of war, German bombers could easily deliver a knockout blow. By 1938, this knockout blow could be delivered in just 24 hours. The British government asked a group of scientists to explore the feasibility of using radio waves to create a death ray which could shoot down or cook approaching bombs. Instead, scientists demonstrated how radio waves could detect and range aircraft, and radar was born. However, technology alone was not enough. Working in close partnership with RAF officers, the new team was able to combine scientific research with operational experience to create the greatest air defence system in the world. This groundbreaking approach was rapidly integrated into a network of both military and civilian defence assets. With operational research, it enabled the earliest possible detection and interception of enemy aircraft. By the Battle of Britain, radar had increased Fighter Command's defensive capability by a factor of 10, and operational research doubled this to a factor of 20. In 1948, the Operational Research Club was founded, which 5 years later became the Operational Research Society. After the war, the scientists and officers involved in this pioneering approach found jobs in government, manufacturing, banking, health services, business, transport, defence, sport, and well beyond, taking the knowledge and insight of operational research with them, where it has been solving problems and supporting decisions with science ever since.
Thank you. Can you go back to the slides? So this is a very short video. You can go to the YouTube, you can type the OR Society, and you can look at this video. The purpose of this video is this highlights what all areas you can apply operations research for your decision making. Okay? So when I talk about decision making, you can see that there are problems where you can apply and what are the key techniques. Okay? Now when I talk about techniques in OR, the fundamental technique is optimization. Okay? Now way back in high school, all of you would have learnt about maxima and minima of functions. Yes? That was also optimization. You're optimizing a function. Only difference there was you were working either with functions of one variable or functions of many variables. That's how you would have thought. You have been taught, right? Calculus, right? Now, suppose consider a situation where I have a function which I want to optimize. By optimize, I mean I want to maximize or minimize. But now it is in a constrained world. Okay? For example, let me give you a simple example. If you are a person who is actually making a baker who is selling cakes and biscuits, what do you need for cake and biscuit? Maida and sugar and some butter. Okay, you are a baker who is making cakes and biscuits. You are selling one cake at 10 rupees per piece and one biscuit at 1 rupee per biscuit. Okay, now your decision is how many cakes and how many biscuits you should make. That is a decision you are taking. Agreed? What would be your answer? And you know that cake and biscuit, both of them require maida, sugar and butter. It might require other things, but I am just keeping this simple. What would be your decision? How many cakes would you make and how many biscuits would you make? I'm giving you as much sugar as you want, as much maida as you want, and as much butter as you want. I'm giving you. You ask for it. I will give you. How many cakes will you make? I am giving you, to make cake and biscuit you need sugar, maida and butter. I am giving you as much as you ask. You ask me 1 kilo, I am giving it to you. Ask me 100 kilos, I am giving it to you. 1000 kilos, I am giving it to you. So how many cakes would you make? What would be your answer?
Based on demand.
Demand is infinite. Demand for cake is always there. So how many cakes would you make? How many would you make? As many as you can, right? That is infinity, right? Okay? But do we live in an unconstrained world? Can you find any person who is giving you whatever you ask? Is anybody giving you whatever you ask? Right? So you are living in a constrained world. Okay, so the same thing which you want to maximize your profit, earlier it was in an unconstrained world, and that unconstrained optimization is what you would have done back in high school. But now you live in a constrained world. Okay, so you're moving from unconstrained optimization to constrained optimization. Now, what does this linear, integer and non-linear programming say? They talk about the nature of this function. For example, if one cake is giving you 10 rupees, okay, how many rupees will you get from selling 20 cakes? 200? One biscuit is giving you 1 rupee, 20 biscuits? What is your total profit? You're adding this, right? So it is suppose you're selling X1 cakes. What is your profit? 10 into X1? Right? And X2 biscuits, what would be your profit? 10 X1 plus X2. So that is your profit. What kind of a function is this? Is this linear? Is this non-linear in X1 and X2? It is linear. Agreed? So all mathematics, nothing more than that. We have represented this profit as a linear function of X1 and X2. What is the decision? How many cakes to make? How many biscuits to do? So we are posing a decision problem as a linear optimization problem. Is this clear? Okay. Now, suppose I go to an integer linear programming problem. Suppose instead of cakes and biscuits, okay, I am interested in knowing how many cars to produce. Okay, suppose the problem is how many cars, how many mini cars and how many sedans, right? Would you agree if I tell x1 equal to 1.75 as an answer? You would want the variable to take integer values. Agreed? You will not accept a fractional solution. In the linear programming framework, you are okay with fractional solutions. Whereas when I'm constraining my variables to be integers, it becomes an integer programming framework. Is that clear? Okay. Again, the decision problem is the same. Now, let's look at nonlinear programming. Have you all learned of what is a demand function and how you can express demand as a function of the price? Anyone knows the economics of that? Yes or no? Not heard of it? Okay, then let me not go there. Let me take some other example. Okay. Instead of telling that have you all seen situations where two products are sold together, bundled together in a shop and offered at a discount? Have you seen situations that kind? Okay. Suppose I am buying a cake and a biscuit and the shopkeeper says that you buy the cake and biscuit together, I'll give you a 5 rupee discount. Have you heard of this together? If I bought the cake separately, it would have been 10 rupees. If I had bought the biscuit separately, it would have been 1 rupee. But I'm buying both of them together, he's telling, okay, you take it for 8 rupees. Which would have otherwise been 10 plus 1. Now I'm getting at a bundle cost. This bundling is not a linear addition of these two. Do you see that? But it would be some other function. Is that clear? So linearity comes down. What is happening is non-linearity starts kicking in. So many a time you might not be able to just have linear functions. You might need non-linear functions. Okay. Now, from a decision perspective, your non-linear programming functions are very evident in what we call pricing models, where based on a demand, okay, I decide on what should be the price of a product. Okay, what should be the price of a product based on demand. Now, is this a decision problem? Yes or no? Selecting the price is a decision I need to take. Based on what? Based on maximizing my profit. This profit is going, I can abstract this profit as a function of my demand, and it would be a non-linear function. Okay, so I can come up with a price or the optimum price. Is that clear? Yeah. So you can see that these are what we refer to as mathematical programming techniques. So any OR class will start with these techniques. How many of you have OR as a subject at all? Very few. Okay, so the others, I think I'll be motivating you into learning OR. If there is not being taught in class, you can go to NPTEL. How many of you know about NPTEL? There is an NPTEL platform. In that NPTEL, you have courses which are available. You can look into those courses and you can learn it. The next thing is, I will skip PERT. What is project management? For example, this conference itself is a project. When do you think they would have started planning for this? Yesterday or months before? Months before. So they would have first assumed that, okay, I contact my speakers. If this speaker accepts, okay, I'll put that speaker. If the speaker doesn't accept, I'm going to go to some other speaker. So everything can be viewed as a project. I fix my end date, and what is that end date? That end date is today. I plan well in ahead. Okay. Then afterwards I need to know, okay, how do I plan these people who come? How do I plan everything? So this is what we call a project management technique. OR can be applied to project management also. Okay, so I find out, for example, today's schedule itself. Okay, we are running late. Suppose I tell you that you have to finish at 5 p.m. But we were running late. If I had stuck to 1 hour of every lecture, I could not finish at 5 p.m. So what do? I crash activities. I reduce the duration of certain activities. That's what happened. We reduce the duration. This was taken on a real-time basis. But the mathematical model is what we call project evaluation and review technique. Is that clear? And what is called a critical path method. Now when you look at when you go and look at things from a supply chain, is something maintaining time, please? I think I need to stop at 3. Yes? Right, sir? Okay. Somebody just stopped me 5 minutes before, I'll wrap it up. So I'm not yet done, please. Okay. So one more thing which you need to understand from a supply chain perspective is, how many of you know what is a supply chain? Have you heard this word, a supply chain? Yes, no? All of you have your smartphones again. Let me take the smartphone. This one, where do you go and buy it? In a shop or online. Those are what we call retailers, right? From where do these retailers get their phones? Manufacturers or some wholesalers, right? Now these manufacturers, do they make the phone immediately or do they need raw materials to get into that phone? They need raw material, right? So if you track a phone, you are the consumer, you have the consumer, you buy it from a retailer, the retailer gets it from the wholesaler gets it from the manufacturer gets it from a whole lot of suppliers. This entire journey of the phone from the raw material supplier to the consumer is what we refer to as a supply chain. Okay. Now in the supply chain, what are the problems that are important? A is, does a retailer, do you think this is what happens? You go and place a request at the retailer transfers the request to the wholesaler transfers the request to the manufacturer, and then after you get back the phone, or when you go to a shop and ask for a phone, the retailer gives you the phone. What happens? The retailer gives you the phone. Now, does the retailer know for sure that he is going to get a demand of 500 phones per day, or does he estimate his demand? Is he sure about his demand, or is there uncertainty about his demand? There's an uncertainty, right? So the retailer will place an order of the phones, right? The retailer is going to place an order of, say, he knows that I face a demand of 500 phones, approximately 500 phones a day, goes back and places an order. Okay? Now, if he goes back and places an order with the wholesaler will respond saying that you will get the phones in 3 days. Do you think this is always 3 days, or it could be 4 days, it could be 5 days, it could be 6 days? Is it always, if your wholesaler says such a thing, you will get it in 3 days, do you always get it in 3 days? You could get it in 4 days. So there's an uncertainty there also. So you build in that uncertainty when you will not place 500 phones, you might place 700 phones, because you could get 500 phones in 5 days, you could get 200 phones in 7 days, but at any point of time, you don't want to tell a customer that you don't have that phone, right? So this is what we call as inventory management. How does the retailer manage his or her inventory? Okay, and if you look at the models, these models are again optimization models. You have one period deterministic models, you have multi-period stochastic models, you have one period stochastic models, and you have a lot of OR models in inventory management. Okay? The next thing which I will talk about is queues. As I already said, when you talk about queues, there are two important processes in a queue. One is what is called an arrival process, and one is what we call a service process. Okay? Now, both of them are uncertain. Can I always say that there is one person entering a bank every 5 minutes? Or I can say, do people enter a bank at random? At random. So the arrival process is random. Now let's look at the service process. When you enter a bank and you are getting served by a teller, are you always sure that your service time would take only 2 minutes or 3 minutes? That's also random. Okay, so what is the problem there? How do I manage this queue? And that is what queuing theory says. Queuing theory will help management make better decisions concerning the operations of systems which involve over time. Now, when you look at OR models in general, there are two broad umbrellas. One is what we call analytical models. In analytical models, you actually abstract the situation and come up with a mathematical model. In the simulation model, you simulate the model. What do you mean by simulation? How many of you have known to drive a car? Have you been to these Maruti driving schools where you are taught to drive a car not on a road? You are giving a simulated experience, right? So when you do not have analytical model, you can simulate the model. And that's what Professor Dharmaraja also talked about. When you are analyzing mathematically, if you are not able to analyze it completely with analytical solution, you simulate the model. So simulation is a very, very important tool from operations research which helps you in decision making. So finally, you have decision analysis also, which is about optimal strategies, and it involves several decision alternatives. From a statistical point of view, you do have forecasting methods. You have what is called, again, analytical hierarchy process. This is again an OR tool. And you have what is called Markov decision process. So I will just stop here, but I just want to tell you, because this is a predominantly student-driven thing. Even I have been a student. Even when all of us have been students, we have been there before you have been here, right? Yeah, we know your mentality. We know what is there. It is good to ask questions. Okay, it's very good to ask questions. And it is very good to challenge also. But at the same time, please be open to learn everything. Is that clear? Please be open to learn everything. Not everything that you learn today would be useful. I know at your age, the most important thing is to finish the syllabus and to write an exam and get a degree. That's how all of us were way back. Okay? I'm not even debating that. But at the same time, develop an interest or passion in one of the subjects. Okay? And don't discount any subject as useless. Okay? If you're a pure mathematician, it has its own place. An applied mathematician has its own place. It's not that pure mathematics is superior to applied mathematics is superior. All the superiority complex is developed by people who don't know any subject. People who know the subjects know that every subject is equally important. People who don't know anything will lean on this superiority complex. First of all, maths is not a superior subject in any way. Learn to respect every stream, learn to respect every person, and learn to respect every possible academic pursuit. Okay? Wishing you all the best. Thank you. Anything about IIT Madras or anything, you can ask me. I think I'm loud enough, right? You all can hear me? Yeah. So any questions, I'll be happy to answer. No? None? You can ask also. Not an issue. For those of you who do not know, IIT Madras has actually launched an online BS program in 2019. Okay? This online BS program is a program which a student who is already enrolled in a BSc also can do it. Now UGC allows you to be enrolled in more than one program. Okay? The advantage is you can do it at your own pace. If you can do only 2 subjects at a time, you can enroll for 2 subjects. If not, you cannot enroll. You don't have to. Okay? And it has exits. If you just get out after a year, you'll be given a certificate. If you complete after 2 years, you'll be given what is called a diploma. If you do it in 3 years, you get a BSc. If you do it in 4 years, you get a BS. Okay, and this you can do very well with whatever programs you are currently enrolled as full-time students, right? And there is so much available online. I really recommend you all to be more open, more flexible. There is so much. The time we spent on all these OTT platforms, spend a little outside the OTT platforms. It would be very helpful and useful to you all. Okay? Thank you. All the best. Thank you.
On behalf of Postgraduate and Research Department of Mathematics, I extend my sincere gratitude to our resource person, Dr. Usha Mohan Ma'am, Professor, Department of Management Studies, IIT Madras, for enlightened and depth knowledge on operation research models for better decision making. This session was very useful and interesting, ma'am. We are delighted to have you with us, ma'am. I hope that all the participants would have gained the knowledge on this topic. I assure you, ma'am, that it will help, especially for young researchers, to proceed further in this area. I thank all the participants for their proactive participation. Thank you.
Only one change is I did not talk about any topic. I just introduced you people to this. Now to pursue it or not is your call. Okay? You take a decision. So I've helped you. I've just ignited. Okay? I've used this ignition to start it. Now you people drive it. Okay? Bye.
தாமோதரன்
data point எடுத்துறோம் சார். எஸ்
சேஞ்ச் பண்ணுறது ஸ்லைட் சேஞ்ச் பண்ணுறது ஆட்டோமேட்டிக்.
அங்கே சார் இது வந்து லைவ் போயிட்டுருக்கு அந்த சிஸ்டம் தான் சார். அது கனெக்ட் ஆகுத பார்ப்போம் சார். அப்படி இல்லைன்னா அங்கே யாராவது ஒருத்தர் உட்கார வச்சு நெக்ஸ்ட் இது பண்ணிடலாம்.
Good afternoon to one and all present here. Here I am welcoming and introducing Dr. G. Anthony Brito Xavier. Sir has joined as a lecturer in the Department of Mathematics in the year 1994 in Sacred College, Tirupattur. He was appointed in the regular aided post in the year 1998. He became an associate professor in the year 2011. He obtained a PhD. He obtained a PhD in the field of difference equations from Tiruvallur University in the year 2010. He has 24 years of teaching experience. He holds BSc 1988 and MSc 1990 from Madurai Kamaraj University and MPhil 1991 from Manolmaniam Sundaranaar University. He has published 150 publications in reputed international and national journals. He has published 3 books with ISSN numbers. He holds to his credit being invited to be a resource person in 1 international and 80 national conferences. He has organized 9 national and international conferences, and he has already guided 55 MPhil scholars, 12 PhD scholars, and presently 5 PhD scholars are doing research under his guidance. His field of research interest research interest includes difference equation, partial difference equation, and fractional calculus. Presently, he is serving as an academic council member of the Tiruvallur University, Vellore. From 2017 onwards, He is head of the postgraduate section of the Department of Mathematics Shift 2 for 3 years. He is also the editor-in-chief of the Journal of Computational Mathematica. He is a founder and president of Academia for Advanced Research in Mathematics, AARM Society. He is also the life member of the Indian Mathematical Society, Academy of Discrete Mathematics and Application, and the Father Academy of India. He has visited 3 countries, namely Portugal, Italy, and France. I welcome you all, sir. I request our HOD to felicitate Rito sir.
Very good afternoon. My sound is not perfect. Please bear with me. Okay. Thank you very much for nice introduction about me, and I thank the management for organizing this wonderful international conference on applied mathematics and computing. Okay. So you are UG students or PG students? Both UG and PG. Oh. You should learn at least 1 or 2 points, 1 or 2 concepts. Okay. It should learn at least 1 or 2 concepts through this night talk. Otherwise, 1 hour is best. Okay. Are you a good listener? You can learn a listener than so this is a very simple concept. What is the title of the international conference? Applied mathematics. So there is an atom. It connects physics. Okay. Then groups. You know the algebra concept. You know the graph theory. And you know the calculus. So everything is over. Algebra, graph theory, calculus. Connect all these 3 concepts. You can develop your research work. I would like to ask you one question. Can you publish a paper using 1 and differentiation and integration? By using number 1 and differentiation and integration, can you publish a paper? So research is not difficult. You can enjoy the research. Okay? We can enjoy the research through this talk. If you are a good listener, right? And I would ask you one question. If you remove all the empty space from my body, if you remove all the empty space from my body, what will happen? What will happen? I will answer this question end of this session. Okay? Okay. Which number is created by God. God's number 20. Okay. Any other answer? God has created 1. Then 1 becomes 2. 2 becomes 3. 3 becomes some x. So x belongs to natural number, implies x plus 1 is also a natural number. This is the rules of natural number. 1 belongs to natural number, God created number. If whenever x belongs to a set n, x plus 1 belongs to set number also. Natural number. So this is the natural number or God's number. Okay. Now, go to next slide. What is the aim of this? My talk is, if you have any doubt, please ask me. No problem. Our aim is to introduce a graphical representation of a group. So, graphical representation of a group obtained by applying higher order derivatives of exponential function. So, group, graphical representation, higher order derivatives. So, this talk includes 3 areas. Okay? Group theory, graph theory, calculus. Particularly fractional calculus. Have you heard of fractional calculus? Do you know how to differentiate x square? What is the differentiation of x square? One type differentiation of x square is 2x. Do you know how to differentiate x square half times? Half times differentiation. Or 0.3 times differentiation. Is it possible? Yes. So that is the end of my talk. Okay? Next one. Previous one. Yes. What is the limits of a graph? What is the limits of a graph? Graph is a pair of vector sets and edge sets. It's a pair of two sets. What is the condition on first set? There are 2 sets. First set is called a set of vertices. Any condition on the first set? First set should be non-empty. What about the condition on second set? Edge set may be empty or non-empty. Okay. Empty or non-empty. Okay. So if you are given, so can you form a graph? Take all the participants in this room. Take each person as a vector. Take the edge set as empty set. So we are in the graph. Graph is everywhere. It is in the atom also. It is also in the atom. So to construct graph, we need only 2 sets. First set is non-empty finite set. Second set, each element in second set should be represented by 2 elements of vertices. 2 vertices, if you have take 2 vertices, we can form an edge. Okay, so the condition. Then this one, what is group? Graph is a pair of 2 sets. What is group? Finite group. Group is a non-empty set. Graph is a pair of 2 sets, but group is a non-empty set with a binary operation. Here pair of 2 sets, here 1 set and a binary operation. Using this binary operation and an element from a group, can you make a edge set? Alright? What is the group? Is a non-empty set. Take the group as a vector set. Take 1 element from that group, we can form a edge set. Clear? So if you are given any group, we can form different types of graphs. If you are given any group, we can form a graph using the group and a binary operation. For example, what is Z4? What is Z4? Is it empty set or non-empty set? It's a non-empty set. How many elements are there? It has 4 elements. Labeled as 0, 1, 2, and 3. So vector set is over. We have a vector set. Take the group element as is vector set. What is necessary to form a graph? You need a vector set already over. Huh? Take the group as a vector set. Edge set. We have to construct edge set. But there is a binary operation in Z4, right? What is a binary operation? Not usual addition, modulo 4. If the number is beyond 4, divide it by 4 and write the remainder. Okay? So now Z4 is a group. I make it as a graph. Okay? Now take any one element from Z4. So what is vector set? What is vector set? It's a non-empty set. Here 4 elements are there. If you take the edge set as empty set, suppose edge set as a empty set. So what is the graph? Z4 comma empty set. So empty set allowed or not allowed? Empty set allowed for edges but not vectors. Therefore, this graph is called, in one of it, this graph is called disconnected graph, null graph, empty graph, whatever may be. Okay? This every graph, every group is a. So what is the conclusion? Every group is a graph. Take the group as vector set and the edge as empty set. Okay? So you have learned one thing. What is the every group is a graph. If it is finite group, well and good. Okay? Next level, you take any element from this group. Suppose, okay, next one. What is V4? Contains how many elements? V4 contains how many elements? 4 elements. 0, 0, 1, 2, 3, 4 elements. We have a binary operation. We have a binary operation. What is the binary operation? Plus 4. Take one element. For example, 1 belongs to V4. Okay? 1 belongs to Z4. 1 Z4 இருக்கா இல்லையா? இருக்கு. அந்த 1 ஐயும் Z4 use பண்ணி we can construct an edge set. What is the mantra for making the edge set? Simply take one. 0 is an element. 0 is connected with 0 plus 1. 0 is connected with 0 plus 1. So this is one edge. 0 goes to 1. Then 1 is connected with 1 plus 1. So 1 is connected with 2. Then 2 is connected with 2 plus 1. So 3. 3 is connected with 0 plus 1. So what is the edge set? 0, 0, 1, one edge set. 1, 2, another edge set. 2, 3, another set. 3, 0 is set. See, if you are given a group and one element, we can form a graph. This looks like an atom. It's not? I will tell you later. So what is the name of this graph? It's a cyclic directed graph. Is it cyclic graph? Starting point and end points are same. Okay? So it is a cyclic graph. So if you are given any group and an element, we can form a graph. Next, if you take 2 elements, there's a mistake. What are 2 elements? 1 and 2. Form the edge using 1 as well as 2. Using 1 and 2, you can form a edge set. What is vector set? Is fixed. 0, 1, 2, 3. Vector set is fixed. Which one is ready? The edge set. This depends upon our creativity or need. Okay? If you take two elements, we can get a complete graph. So 0 goes to 0, 1. Then 1, 2, 2, 3, 3, 4. Take the second element 2. 0 goes to 2. 0 plus 2, 2. So 0 is connected with 2 by using the element 2. Then 1 is connected with 3. 1 plus 2 equal to, what is 1 plus 2? 3. So vectors 1 is connected with 3 by the use of, use of 2. So by 1 and 2, we can form a graph. This graph is a complete graph of 4 vectors. So I say if you want to complete a project in PG level, you can do so many graphs. You take any group, take two elements, form a graph. You take another ring and form a group, you complete the project. So there are so many possibilities are available. Okay? As a research scholars or project students, you can do many research. So this is the basic definition of construction of AG set. Okay? So A goes in AB. Take one element from a group, form a AG set. That's all. So if I given any group, you can form a graph. So I have connected two areas. What are two areas? Algebra and graph. Next we can go to the calculus part. Okay? Calculus part. Next one. Can construct a graph or group using demonstration and integration of 1. How many of you know how to integrate 1? Do you know how to integrate 1? What is integration of 1? X. Okay. What is demonstration of 1? 1 times demonstration of 1 is 0. 2 times demonstration of 0 is 0. 3 times demonstration of 0 is half times demonstration of 1 is 1 times demonstration of 1 is 0. 2 times demonstration of 1 is 0. 3 times demonstration of 1 is 0. N times demonstration of 0 is n times demonstration of 1 is 0. What are half times demonstration of 1? Usually we fix that it is 0. Any times demonstration of constant value equal to 0, but it is not correct. On the other hand, what is 1 times integration of 1? 1 times 0 times integration of 1 is 1. No integration here. 1 times integration of 1. What is our aim? Using 1, we are going to write a thesis. Using 1 and the integration, we are going to write a big project. Only knowing 1 integration differentiation, nothing else. Okay? 1 times integration of 1 equal to from 0 to x by 1 factorial. Again, 2 times integration x by 1 factorial. Again integrate x square by 2 factorial. Is it correct? 0 to then. What about 3 times integration of 1? S cube by 3 or 3 factorial? 3 factorial. Once again you will write s cube by 3 factorial. S power 4 by 4 factorial. What is n times integration of 1? N times integration of 1 is x power n by n factorial, but n times differentiation of 1 equal to 0. You listen, n times differentiation 0, but n times integration of 1 becomes x power n by n factorial. Here I am using only 1 and integration. You add all these integration values, you add all the terms. What is 0 times integration of 1? 0 times integration of 1 plus 1 times integration of 1 x by 1 factorial plus 3 times integration of x cube by 3 factorial plus. What is it? 1 plus x by 1 factorial plus x square by 2 factorial plus x power n factorial. What is it? E power x. Whether this series converges or not? E power x, put x equal to 1, put x equal to 1, 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. It converges to e power 1. It takes x equal to 100. Take x equal to 100. 1 plus 100 by 1 factorial plus 100 square by 2 factorial plus 100 cube by 3 factorial, etc. So this converges to e power 100. For this exponential function, the radius of convergence is infinity. Radius of convergence is infinity. So you can take any value for x. Any value for x. 0 to minus infinity to plus infinity. Okay. Now, another question. Can you make this exponential function as a graph or group? In the exponential function, can you make it a group or graph? Oh, my thought is over. I started one, I integration. Next question, is it possible to extend this exponential function to fractional order exponential function? Second part. First part, integer order exponential function. Second part, fractional order exponential function. So, theory analysis says that this series converges. I want to share all these properties to 3 or 4 members of these participants. Okay? I want to share all the terms of e power x. The e power x element we are going to form a graph as well as a group. Okay? So project work. What is e power x? 1 plus x by 1 factorial, x squared by 2 factorial. I want to share all the terms of this e power x to 1, 2, 3, 4. Okay? First one, your name is e 0 by 4. Your name is 0. First, take 1. First one goes to madam, first madam. Okay? Then x goes to next fourth jump. 1 plus x power 4 by 4 factorial. Take the after fourth term x power 8 by 8 factorial. Then 8 power 12 by 12 factorial goes on. These properties are given to the first madam. Okay. Then second madam, I give what is the number previous to x power 4? X power 3 by 3 factorial. So x power 3 by 3 factorial plus take the jump value 4. What will happen? X power 7 by 7 factorial. Then x power 1 by 7 factorial. Next x power 15 by 15 factorial. All these properties are given to the second version. Okay. Then what is the previous to x3 factorial? X power 3? X power 2 by 2 factorial. So partition by 2 factorial, x power 6 by 6 factorial, x power 10 by 10 factorial. These properties are given to the third person. Okay? But third person name is E 3 by 2 by 4. What is fourth person? E fourth part. X by 1 factorial, x power 5 by 5 factorial, then x power. I took 1, I make integration and find the exponential function and sharing. எது கிடைச்சாலும் ஷேர் பண்ணணும்னா அப்பதான் லைஃப்ல நல்லா ஆக முடியும். அப்பதான் ப்ராஜெக்ட் வரும்ல. So okay, sharing is very important. I farm, okay. I earn money through salary. சம்பளம் share பண்ணுவேனா? என் வீட்டுக்காரமா அடிச்சு போடுவாங்க. அதே கொடுத்தவங்க தான் மகான்கள். கொடுத்த மகான்கள். இன்னும் ஆஃப்டர் ஒரு 50 years அப்புறம் அந்த படம் யார் யூஸ் பண்றாங்கன்னு தெரியாது. ஆனா கொடுத்த மனசு வராது. ரைட்? ஐம் ரைட்? ஸோ ஷேர் பண்ணணும். ஸோ E for X sharing parts into 4 part. Okay. Then now what is the vector set? I take these 4 fractions as a vector set. E 0 by 4, E 1 by 4, E 2 by 4, E 3 by 4. Okay, 4 by 4 again 0 by 4. Okay. So vector set over. You have to consider AG set. What is AG set? First property is connected with the second property. Who is the connector? One time differentiation. If you differentiate previous one. If it previous one. Okay. What is the differentiation of E0 by 4? Consider E0 by 4 as a one vertex. Okay, it is not a single vertex, it is a family of vectors. Family of vertices. You can change the values of x. Values of x from minus infinity to plus infinity. Here it is a single vectors, it is not a single vector, it is a family of vertices. When you vary values of x from minus infinity to plus infinity. But it looks like a single vector. So property is not a single. Minus vary x from minus into plus infinity. You are very rich. Okay. So what do you get if you differentiate E0 by 4? What is differentiation of 1? 0. What is differentiation of x power 4? 4 into x power 3. This 4 and 4 factorial. What is the 4 factorial? 4 into 3 into 2 into 1. You can cancel 4 and the so you get the x power 3 by 3 factorial. Then what is the differentiation of E1 by 4? E1 by 4 is a notation, okay? Will you get E2 by 4x? If you differentiate E1 by 4x, you get, you can enjoy the research, okay? You can enjoy, you can play with the max. So what is research is a game with playing with the numbers and logic. Okay. Then what is differentiation of E3 by 4x? If you differentiate E2 by 4, you will get a E3 by 4. If you differentiate E3 by 4x, you will get it's a cycle, 0 by x. But 1, then E power x, then sharing, again differentiation, there is a cycle. So what is the vector set? What is the vector set? E0 by 4, 1 by 4, 2 by 4. If you are interested to project in university, you take 5 partitions, or you take 6 partitions, or 7 partitions, or 8 partitions, you will get a project work. Okay? Then, what is AG set? E0 by 4 is connected with the differentiation of E0 by 4 is connected with the 1 times differentiation of E0 by 4. What is 1 times differentiation of E0 by 4? What is 1 times differentiation of E0 by 4? E1. So E0 is connected with the E1. What is 1 times differentiation of E1 by 4? E2. So E1 is connected with the E2. And E2 is connected with the E3. And E3 is connected to what is E0 by 4. It looks like a cycle. Take the Bhagavan. Who is the Bhagavan? E power x. Take the E power Bhagavan as a center point. So everything is rotating. So we will get an atom graph. Get an atom graph. What is my question? God created atoms. God created empty space only. The God remove all the empty space from our body, we will disappear. For information, suppose this is an atom. What is the size of the atom? 10 raised to minus 10. The size of the atom is 10 raised to minus 10. But what is the size of the one electrons? Center is neutron. Take the vectors as electrons. Size of the electron is 10 raised to minus 15. Size of the atom is 10 power minus 10, whereas the size of the electron is 10 raised to minus 15. What is the difference? 10 raised to minus 5. 1 lakh times there are empty spaces are there. How many times empty spaces are there? 1 lakh times. So that the signals are printed towards the room. The room are electromagnetic cross பண்ணுவாங்க ரீசன் என்ன? ஒவ்வொரு ஆட்டம்லயும் 1 lakh times என்ன இருக்குது? Empty space. அதனால சிக்னல் வருது எலக்ட்ரோமேக்னெட்டிக் சிக்னல். ரைட்? நம்ம டோர் க்ளோஸ் பண்ணி எப்ப பேச முடியுது சார் மொபைல்ல? பாருங்க 1 lakh times. If you diminish my body 1 lakh times, என்ன 1 lakh times diminish பண்ணிருங்க. என்ன கிடைக்கும்? Nothing. Google create card வந்து ஒரு empty space மட்டும் உருவாக்காத போதும். We are existing. So that is Bhagavan. Okay? So next time, if you take, this is called second derivative graph. Second derivative graph. What is the second derivative graph? E0 is differentiated how many times? 2 times. So E0 is transferred to E2 and E2 is transferred to E1. There is a rotation. E1 is transformed to E3 and 2 times differentiation of E3 is E1. So this is another type of electrons, movement of electrons. Next one, if you differentiate 3 times, 0 becomes 3, 1 becomes 0, 2 becomes 1, that is a rotation. So 1 times first derivative graph, second derivative graph, third derivative graph. What is fourth derivative graph? Self-rotation. If you differentiate E0 by 4 times, no change. So self-rotation. E0 by 4 times differentiate panna enna E0 by 4. 1 times 1, 2 times 2, 3 times 3, 4 times again 0. Okay, am I right? So self-rotation. adana ரொம்ப பணக்காரங்க நினைச்சு யாரையும் மதிக்க மாட்டாங்களா? அதானா ரொம்ப மனதா இருந்ததுக்கு அப்புறம் யாரையும் மதிக்க மாட்டோம். அங்கேயே சுத்தி சுத்தி நிற்க வேண்டியதான். Okay, you have respect other peoples also. Okay, other people also. Okay, so this now from the exponential function we have created a graph, not a first one type graph. First order graph, second order graph, third order graph, fourth order. Suppose if you have five partitions, how many type of graph you will get? 5, first and second. N times n. So it's a general theory. You can write a bracket, no problem. Okay. Then I want to make it a group. First exponential function, then graph. Similarly, you can form a group. Just one. International one, again international one, again international one, again international one, and all the things we create properties, import x. Then after getting all the properties, share to the people, neighbors. Then we get a graph as well as a group. So what is group? So take 4 vertices. What are the 4 vertices? 0 by E0 by 4, 1 by 4, 2 by 4, 4 elements are there. So form a binary operation. This is not ordinary operations, binary operation. What is binary operation? Says that 0 by 4 plus 0 by 4 equal to 0 by 4. Then 0 by 4, 1 by 4, 1 by 4. So 0 by 4, 2 by 4, 3 by 4. 1 by 4 into 1 by 4. E1, 1 plus 1, 2. I 2 by 4. 1 by 4, 3 by 4. 1 by E, 1 by 4 plus E, 3 by 4 becomes. So E 1 by 4 act as a first derivative. E2 by 4 act as a second derivative. And E3 by 4 act as a third derivative. Okay. Now we have a group. Since the table satisfies the KLS conditions, each row has only one, not repetition, huh? No repetition in each row. There are repetitions in Kapanda. In the repetitions in that. So it is a KLA table. So it is a group. Am I right? KLA table is a group and confirm करते हैं. Repetition वाले को आते हैं எல்லா element में appear आना. Okay. It's a. So what is inverse of 1? And inverse of 1. 1 inverse of 0 and 3. E1 inverse E3 with respect to addition. Next one is a group. This group is called an atom group because next from this group we can form a graph. From a group we can form a graph. What is the graph? Take one element from the group, we form a SG set. That's all. One element group from the and the element is பண்ணி form a SG set. Already vector set is over. We got a vector set. Then we will get a graph. Okay. And take here e power x union then the graph here. E0 by 4 goes to who is the hero here? Who is the hero here? E1 by 4. What is the partial element? E1 by 4. So E0 by 4 goes to E0 by 4 plus E1 by 4. What is E0 by 4 plus E1 by 4? E1 by 4. Then E1 by 4 plus E1 by 4. E1 by 4 is connected to E2 by 4. E2 by 4 is connected with the connect ஆயிருக்காங்க. E3 by 4. E3 by 4 is connected with the 0 by 4. So vector substitute over. We have the edge set. Is a one variety graph, first variety graph. First variety graph தானா 0 1 ஓட கனெக்ட் ஆகுது 1 2 ஓட கனெக்ட் ஆகுது 2 கனெக்ட் வித் 3 3 கனெக்ட் வித் 4 0 okay. So first derivative graph. So this group is called the first derivative group. In order to E1, you take E2 by 4. If you take E2 by 4, this graph, this one, this graph, 2 by 4 graph. Here 2 by 4. Who is the hero in here? Hero in here. 2 by 4. அவங்க சொல்றதா எஜி. யார் ஹீரோயின்? 2 by 4. ஜீரோ யாரா மாத்தி விடுறாங்க? யார் கூட கனெக்ட் பண்றாங்க? 2 by 4 கூட. E1 யார் கூட கனெக்ட் ஆகுறாங்க? 3 by 4 கூட. 2 4 by 4. By taking E2 by 4, we can find a graph. We take the Bhagavan as a center point. Okay, we can get a graph. Yes. So, using exponential function, we can form both group as well as graph. Okay, so this is the notations PPT கொடுத்துட்டு if you want you can copy it. Okay, project பண்ணல யூஸ் பண்ணிடுங்க no problem. இது ஜெனரல் தியரி நான் 4 or 5 times 6 times 10 times n times க்கு theorems டெவலப் பண்ணிருக்கேன் but you don't confuse that na பொறுமையா படிச்சு பார்த்தா தான் புரியும் இந்த தியரி பார்ட். ஓகே okay. So partition n partitions 4 1 3 வச்சேன்ல அது உங்களுக்கு எத்தனை டைம் பண்ணிருக்காங்க partition n times. And then participate with it, you will get a theory part. Okay. Start next one. So this is graphical part. Next one. E0 vertices is odd times differentiation. How many times differentiation? E1 sorry, not 1 by n, I by n question the odd times differentiation of d I by n. So this theory part okay. Let's stop. அப்படியே எடுத்துங்க 6 times 5 times. இப்போ இந்த ரிசர்ச் கன்வெர்ட் பண்ணுங்க. How will you make it a research paper? இந்த திரும்ப சொன்ன பாருங்க இந்த எக்ஸ்போஸ் ஃபங்க்ஷன் அப்படியே இருக்குல்ல நெக்ஸ்ட் லெவல் எப்படி பேப்பரா பப்ளிஷ் பண்றது? Exponential function. What is exponential function? 1 plus x times 1 factorial x square by in the existing exponential function வந்து இது புதுசா ஒரு exponential function கண்டுபிடிக்க முடியுமா? Can you find out a new exponent function? Other research. Think பண்ணி பாருங்க எப்படியெல்லாம் மாத்திக்கலாம். தப்பா இருந்தா கூட பரவாயில்ல. You write something. Equals வந்து எப்படியெல்லாம் பிரிக்கலாம் ரிசர்ச் பண்ணலாம் யோசிச்சு பாருங்க. 1000 times of research we can make it. Not a single group na research ki thousands of ways are there. Equals இருக்கா அடுத்து என்ன பண்ணுவீங்க ரிசர்ச் மாத்துறதுக்கு? Equals குரூப் ஆ மாத்த சொன்னேன் கிராஃப் ஆ மாத்த சொன்னேன். அப்படிதானே? அதே மாதிரி நீங்க இன்னொரு யோசிச்சு பார்த்தா மாத்த முடியுமா? Can convert e power adanga e power ms over ms to x dx. Okay, one times integrate பண்ணுவீங்களா? One times integrate பண்ணுவீங்களா? What is e power x? 1 plus x power 1 by 1 factor. ஏன் x power ஆஃப் போடக்கூடாது? யோசித்தீங்களா? x power 5 divided by 5 factorial ஏன் போடக்கூடாது? Then x power 1 by 1 factorial plus x power 1.5 by 1.5 factorial. அப்படி யோசிக்கணும், திங்க் பண்ணணும். What is the difficult is what is 1.5 factorial? அந்த ப்ராப்ளம் வரும். நம்ம என்ன பண்ணி பேசலாம். அங்க நம்ம என்ன செய்யலாம்? 1000 ரூபாய் ரெஸ்பான்ஸ் யாரோ ஒருத்தர் ரெஸ்பான்ஸ் ஃபங்க்ஷன் கண்டுபிடிச்சாரு நான் அப்படியே இது பண்ணா நோ ரிசர்ச். அதுக்கு மேல ரைட்டா யோசிக்கணும். தப்பா இருந்தாலும் பரவாயில்ல. ஐயோ ஆஃப் ஃபேக்டோரியல் எவ்வளவு கண்டுபிடிப்பேன்? 1.5 ஃபேக்டோரியல் எப்படி கண்டுபிடிக்கிறது? What is 2 factorial? 1 into 2. What is half factorial? பிரச்சனை வருதுல்ல? ஐயோ ரிசர்ச் வரல. half factorial என்ன அர்த்தம்? half factorial என்ன அர்த்தம்? gamma of ஒன்னு ஆட் பண்ணுங்க. gamma of half plus 1 1.5. gamma 1.5 தான் என்னது? half factorial. 2.5 factorial equal to gamma of 3.5. Common idea is very easy. What is minus 1 by 2 factorial? What is minus 1 by 2 factorial? Common of very good. Root 5, very good. Gamma of 1 by 2 equal to root 5. Gamma 1 by 2 using gamma of 1 by 2, we can find minus 1 by 2 factorial, minus 1.5 factorial, minus 3.5 factorial in the cell. This is a 2.5 factor. Anything we can find by reduction formula. Okay. So what is now e power x is expanded to e power 1 by 2x. So that is 1 plus x power 0.5 factorial. What is 0.5? X power. Then how will you write this exponent function? Go back. Okay. 1 times integration of 1. 2 times integration of 1. What is t by 2 factorial? What is n times integration of 1? T power n by n factorial. Why should integrate 1 n times? Is it possible to arrive this result by only 1 times integration? ஒரு தடவை இன்டகிரேட் பண்ணாலே எனக்கு n டைம்ஸ் இன்டகிரேஷன் வருமா? அதான் क्वेश्चन. n டைம்ஸ் இன்டகிரேட் பண்ணா I don't want waste my time. ஒண்ணு n டைம்ஸ் இன்டகிரேட் பண்ண கஷ்டமா இருக்குது. எத்தனை இன்டகிரேட் பண்ண போறேன்? ஒரே ஒரு டைம் இன்டகிரேட் பண்ண போறேன். ஃப்ரம் ஒரு கேர்னல் ஆட் பண்ண போறேன். ரெகுலர் வெளிய ஒரு கேர்னல் கண்டுபிடிச்சாங்க. அது எதை ஆட் பண்ண போறேன்னா what is n times integration of 1 equal to 1 by n minus 1 factorial into common times 1 times integration. அந்த பேலன்ஸ் பண்றதுக்கு என்ன மல்டிப்ளை பண்ணிருக்காங்க? t minus x whole power n minus 1. அப்போ n times integrate பண்ண வேண்டாம். It is enough to integrate only 1 time. What is the adjustment? அதுக்கு ஒரு adjustment பண்ண போறோம். பண்ண என்ன 1 by n minus 1 factorial and சேர்த்துக்கிட்டு இன்டகிரேஷன்ல ஒரு கர்னலை மல்டிப்ளை பண்ணணும். வாட் இஸ் கர்னல்? t minus s whole power n minus 1. அவ்வளவுதான். நீங்க இன்டகிரேட் பண்ணி பாருங்க, கரெக்ட் ஆன்சர் வரும். இப்போ n டைம்ஸ் இன்டகிரேட் பண்றதுக்கு ஃபர்ஸ்ட் என்ன அட்ஜஸ்ட்மென்ட்? 1 by n minus 1 factorial இந்த இன்டகிரல் 0 to t minus x power n minus 1 into என்ன ஃபங்க்ஷன் அப்படியே வச்சுக்கோங்க. இப்போ half times இன்டகிரேட் பண்ண என்ன பண்ணணும் சொல்லுங்க பாருங்க. half times இன்டகிரேட் பண்ண என்ன பண்ணணும்? என்ன அட்ஜஸ்ட்மென்ட்? 1 by half minus 1 factorial minus half factorial. What is minus half factorial? Gamma of 1 by 2. What is gamma 1 by 2? Root pi. So already result is available. In the integral 0 to t minus x power, what is n? 1 by 2 minus 1 into 1 into the fractional integration of the c. That is fractional integration. Half times new times. Okay? So in general, d power minus means integration. D power 1 by 2 is differentiation. D power minus 1 by 2 means integration. Half times integration are negative or not. What is integration? Integration equal to 1 by d. Integration equal to 1 by d. What is 1 by d? D power minus 1. If the power is negative, then it is integration. Okay? Then we can enjoy the fractional calculus by the formula. What is the formula? 1 by n minus 1 factor into integral 0 to t minus x power n minus 1 into f of x into dx. So this is the fractional times integration. This so what is half times integration of 1? What is half times integration of 1? T power half times integration of 1 t power அதை இன்டகிரேட் பண்ணுங்க. இன்டகிரேஷன் ரைட்டா? what is the value? T power 1 by 2 by 1 by 2 factorial. As usual, what is 1? 1 into t power 0. T power 1 into t power 0 है ना? 0 half times इंटरग्रेट बनाने चला. T power 0 plus 1 by 2 divided by 1 by 2 factorial. And 1 by 2 1 by 2 factorial. Then what is half times integration of t power 1 by 2 by 1 by 2 factorial? T power 1 by 2 by 1 by 2 factorial. इन्होंने इंटीग्रेट பண்ணா என்ன கிடைக்கும்? half times by substitution. Then we substitute பாருங்க என்ன time. I don't want waste the time. Substitute பண்ணனும். அப்புறம் இந்த கிளாஸ் நடத்துற மாதிரி ஆயிடும். செமினார் ஆயிடும். T power 1 by 2 by 1 by 2 factorial integrate half times integrate பண்ணா என்ன கிடைக்கும்? 1 by 2 1 by 2 add பண்ணீங்கன்னா ஆகும். T power 1 divided by 1 factorial. இந்த செமினார்ல அட்லீஸ்ட் fraction times integration கேள்விப்பட்டீங்களா? அட்லீஸ்ட் இருக்குமா கேள்விப்படுவீங்களா? T power 1 by 1 factorial half times integrate பண்ணீங்கன்னா ஆகும். T power 1 T power 1 by 1 by 2 add பண்ணுங்க divided by 1 by 2 factorial. Okay? Okay, 2. Then integrating again and again and again, you will get fractional order at all the terms. You will get fractional order exponential function. 1 half times integrate பண்ணுங்க. Again 1 time, 1.5 times, 3 times, 3.5 times integrate பண்ணும்போது you will get exponential function, fractional order exponential. So this is the formula. What is the formula? Half times integration of t power n by n factorial equal to t power n plus 2 by n plus 2 factorial. Okay? That's true. Then if you add all the terms, first integer times integration, now fractional times integration. You add all the terms, you will get the fractional order exponential functions. What is the difference between exponent and fractional exponent function? And the power எல்லாமே integers. X is called x cube, right? Here எப்படி வருது? 0.5, 1.5, 2, 2.5 goes on. Okay? Now then take the sharing. Share the properties to four persons. Okay? 4 partitions. Now E 0 to 2, K2 denotes the jump value, shift value. What is first one? 1 plus 1 means t power 0 or x power 0. X is called by 2 factorial. Then x power 4 by 4 factorial. Right? Then what is next term? In 0.5 now, x 0.5 by 0.5 factorial plus what is the shift value? 2. 2.5 by 2.5 factorial. Then 4.5 by 4.5 factorial. Then next 1. E 1 by 2. 1 by 2 means t x power 1 by 1 factorial. What is shift value? 2. X power 3 by 3 factorial. X power 5 by 5 factorial. The next E 1.5. Shift value 2. So x power 1.5. X power 3.5 by 3.5. For example, we have 4 partitions. Take the 4 partitions as a vector set. We need the edge set. How do you make the edge set? Take one vector, find half times integration. Take another vector, make a half times integration. You will get a edge set. So vector set, then edge set. We will get a half times integrable graph as well as group. So this is half times integral. So this graph is called the fractional derivative graph. First part, what is first part? Integer derivative graph and group. Now we arrived fractional derivative and fractional integrative graph as well as group. So these types of graphs are called atom graphs. These are called atom graphs. Then one time this is as in the integer case. If you want to project work, you no need to take the partition number 4. You make it 5th partition or 6th partition or 10th partition, whatever you want, you can make it a colorful project. Okay? So have you learned about fraction times differentiation, fraction times integration? In order to half times differentiation, you find half times integration, take 1 times differentiation. Half times integration, then make it 1 times differentiation. Half times integrate பண்ணிட்டு அதுக்கப்புறம் 1 times differentiate பண்ணா என்ன கிடைக்கும்? half times differentiation கிடைக்குமா? So if you want to do research in this fractional calculus, you can enjoy the beauty of the mathematics. Okay? Then this conclusion, my talk connects. Is it useful to you? Whether it is useful or not? So within 1 hour, I make it as much as possible. Okay, but think and do research work. This is not a difficult one. You can enjoy the beauty of the research. So instance calculation with replace differentiation by delta operator, integration by delta inverse operator, forward inverse operator. You can do more and more research work. Okay, thank you for your and if you want to publish them, your articles in the Journal of Computation Mathematica, please contact me. It's a free, open access journal. And if you want to, you are a member of professional bodies, Advanced System, Academy of Advanced Research in Mathematics, then a registered academic body. If you want your membership, please contact me. This is my contact number. If you want to publish the paper in free journal, please contact. I will publish paper for you. Okay? Please contact me. If you have any doubt, most welcome. Please, Nikkei கேளுங்க கேட்பீங்களா கிளாஸ்ல அப்படிதான் think பண்ணுங்க. Okay? So, thank you very much for your patience. And thank you. Once I thank the
Any questions? Any questions from the
Yes,
audience?
please. Of course, this is similar like a integer part, okay? You can plot the graph and find the slope. This is a dimensional function. Every dimensional function is continuous function. Every dimensional function is a continuous function. So slope is possible, no problem. It comes under fractional calculus. Calculus. Thank you. Thank you for this question. And the director, thank you for next question.
Any other questions? The participants, any other questions?
You enjoyed the subject. Enjoy formula. That is enough. And very satisfaction. Any questions?
If not, we will conclude it.
You are any queries or any doubt, please contact me. This is my email address. Thank you.
Thank you, sir. On the behalf of the management and the PG and Research Department of Mathematics, Dwaraka, Goverdhan, Vaishnav College, I would like to thank Dr. G. Brito Anthony Xavier, Associate Professor, Sacred College, Tirupattur. I want to take a moment to express my sincere gratitude for enlightening talk you gave at the Autumn Group and the graph from fractional derivatives. Thank you, sir. Your presentation has been both informative and inspiring and has certainly given us all a lot to think about. The depth of your knowledge and your ability to communicate complex ideas with a simplicity and a clarity is truly remarkable. Thank you, sir. Once again, I thank my professor. Sir is my professor. When I'm studying MSc Mathematics, sir is one of my professors. Thank you, sir. Once again, thank you, sir, for taking time to share your knowledge and expertise with us. Thank you, sir. Thank you. Guys, refreshment is arranged at the back side of the auditorium. Okay, you take this way. Okay, so don't go out and come that side, right? Okay, please take these two ways to get your refreshment. Okay. Students, tomorrow you should be assembled here by 8:30, okay? 8:30 by sharply. Now you can take your refreshment, you can go out. Thank you.
உடம்புக்குள்ள உசுர விட்டு போக சொல்ல நீதான் உன்னை விட்டு போக சொல்லாதே காணுகின்ற காட்சி எல்லாம் உந்தன் பூவம் அது எந்த ஞாபகம் கண்ணுக்குள்ள இப்போ கடல் கசிவத பாரு ஒண்ணுக்குள்ள ஒண்ண வந்து சேரு கண்ணுக்குள்ள இப்போ கடல் கசிவத பாரு ஒண்ணுக்குள்ள ஒண்ண வந்து சேரு காதலுக்கு கண்கள் இல்லை கால்கள் உண்டுதானே சொல் emotion ஆகுறியே
எதுல பண்ணீங்க?
செமினார் ஹால்
ஆன்லைனா?
இல்ல ஆஃப்லைன் இன்னைக்கு பண்ணோம்.
எத்தனை மணிக்கு?
2 o'clock 2:30.
2:30 நாளைக்கு தருவாங்க நினைக்கிறேன். இன்னைக்கு தான் அரேஞ்ச்
இல்ல சார் இன்னைக்கு பண்ணிட்டோம் சார் நாங்க.
சர்டிஃபிகேட் நாளைக்கு கொடுப்பாங்க நினைக்கிறேன்.
அப்படியே சார் நாளைக்கு நாங்க திருப்பத்தூர்லிட்ட வரோம் சார். ஸோ நாளைக்கு வர முடியாது. இன்னும் சரி நாங்க ரெஜிஸ்ட்ரேஷனும் பண்ணிருந்தோம். எங்களுக்கு கிட் கிடைக்கல சார்.
எத்தனை மணிக்கு?
நாங்க வந்தது லேட் தான் சார்.
அதான்மா ஒரு ப்ரொசீஜர் என்ன பண்ணிட்டாங்கன்னா காலைல ப்ரோக்ராம் ஆரம்பிச்சோன்னா அது க்ளோஸ் பண்ணியிருப்பாங்க. ஸோ எகைன் யூ டு இன்ஃபார்ம் டு த கன்சர்ன் பர்சன் ரெஜிஸ்ட்ரேஷன் பண்ணிருக்காங்கல்ல அவங்க தான் சர்டிஃபிகேட் இஷ்யூ பண்ணுவாங்க. ஸோ அவங்க இப்போ 4:30 கிளம்பிட்டாங்கன்னு தெரியல. நீ அட்லீஸ்ட் 2 o'clock you can inform 4:30 will be get ready. But now is already it is gone. I have to check it. நான் பசங்க பிரேக் டைம் ஆகி போச்சுன்னா இப்போ எங்கள் ஸ்டாஃப் இருக்காங்கல்ல அந்த டீம் பசங்க எல்லாம் போயிட்டாங்க நாளைக்கு காலைல வரணும்ட்டு 8:15. நான் மத்தியானம் சாப்பிட்றப்ப பார்த்தேன்னா சப்போஸ் இன்ஃபார்ம் தட் நோ சார் பேசிட்டு கிட்டே சொல்லியிருந்தா அந்த ஒர்க்கில் முடிச்சுக்கோமே. இல்லை நாங்கள் ப்ரெசன்டேஷன்லாம் சரி ஆஃப்டர் 2 to 4:30 சப்போஸ் யூ கேன் இன்ஃபார்ம் ஒன் ஸ்டாஃப் மீன்ஸ் யூ கேன் ஏற்கனவே ஞாமே ரிஜிஸ்ட்ரேஷன் கவுண்ட் யாருமா பார்த்தீங்க? ரிஜிஸ்ட்ரேஷன் கவுண்ட் யார் பார்த்தா? பிரின்சிபலில் சைன் ஆகிடுச்ச சர்டிஃபிகேட்டு பார்ட்டிசிபேஷன் அண்ட் ப்ரெசன்டேஷன் சர்டிஃபிகேட் பாருங்கள். சர்டிஃபிகேட் பேப்பர் ப்ரெசன்டேஷனு ஆர் சேர் பர்சன் இஸ் பிரின்சிபல் சைன் ஆயிடுச்சான்னு பாருங்கள். பார்த்து கேளு உங்கள்கிட்ட. நீங்கள் சப்போஸ் நீங்கள் எமர்ஜென்சி சொன்னீங்கன்னா ஐ கோ டு ஸ்பெஷல் பெர்மிஷன் கெட் த சைன் ஃப்ரம் த பிரின்சிபல். அதர்வைஸ் ஐ கேனாட் கோ அண்ட் கெட் இட்.